What is up, guys? All right, so we're beginning trigonometry, which I guess is triangle measurement. I guess that's what it means. I don't know, it sounds like it. But anyway, I don't think you're ever going to be tested on the definition. Anyway, but trigonometry and right triangles. Okay, so right here I have a right triangle, and in this corner, right, in this angle, we have an angle that I'm naming theta. It's just like if I named it letter A. Okay, this is a Greek letter theta, which is like TH. It's a letter. Okay, but anyway, this is just an angle, and notice this is a right triangle. I've labeled clearly this side right here, which you guys should know is the hypotenuse, okay? But with respect to this angle right here, we have a side across from it that's not the hypotenuse, it's the opposite side. It's on the opposite side of the triangle from that angle, okay? And then we have the side that is adjacent to that angle. The hypotenuse is also adjacent to the angle, but we're gonna call it the hypotenuse, okay? And then we're gonna call this side the adjacent side, okay? And these two sides are the legs of the triangle, of the right triangle, and then you have the hypotenuse. So two legs and a hypotenuse. All right, and what we're gonna do is talk about the 6 trig functions, okay? And so basically what we have, the very first and probably the most famous is called the sine, okay, S-I-N, and that's the sine of theta, okay? And that's going to equal a ratio of 2 sides of the triangle, okay? The sine of this angle, theta, is going to be the opposite side, okay? The opposite side over the hypotenuse, okay? So that is the sine of theta, okay? All right, then we have, next but not less important, we have the cosine of theta, okay? And that's going to be the ratio that is the adjacent side over the hypotenuse. So that's the adjacent side over the hypotenuse, okay? And then we have the tangent, okay? We have the tangent of theta, which is going to be the opposite side over the adjacent side, okay? So the opposite side over the adjacent side, which turns out to be, okay, the sine over the cosine, okay? The tangent, you can memorize that as the sine. This is the sine over the cosine. It works out to be the same thing, okay? So just something to think about. It's a shortcut for later when we do some work, okay? All right, and then we have next to the sine, so I always go in this order. I always list them like this: sine, cosine, tangent, and then I have the cosecant of theta, which is going to be the reciprocal of this ratio, which is the hypotenuse over the opposite side, okay? Then for the cosine, we have the secant, okay, the secant of theta, which is going to be the reciprocal of that ratio, which is the hypotenuse over the adjacent side. And then finally, for the tangent, we have the cotangent, all right? And that's going to be, the cotangent of theta will be the reciprocal of that. So we have the adjacent side over the opposite side. And we also know that since this is a reciprocal here, the cotangent and tangent are reciprocals, then this guy really is the cosine over the sine. So whatever those values are, you can just kind of memorize that. All right, dudes? All right, so let's see if we can evaluate some trig functions. All right, so part A, evaluate trig functions. All right, and what we're gonna do is find the 6 trig functions, okay? Just find the 6 trig functions, so I'll write this down. Find the 6 trig functions. All right, and here's my first example, and probably only example, okay? If I have a triangle that looks like this, okay, and my angle is right here, okay? And I'm telling you that this is 5 and this is 12. All right. All right, I need you to find the 6 trig functions. So we need the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Okay, and by the way, I'll help you with saying those correctly. Okay, well, the first thing we need is to solve this triangle. Okay, so this is a right triangle. That means that the leg squared plus the leg squared equals the hypotenuse squared, right? So leg squared plus leg squared equals hypotenuse squared. Okay, so we know that 5 squared plus 12 squared equals the hypotenuse squared. So that's 25 plus 144, right? So that's 169. That equals h squared. So take the square root, and h equals 13. All right, so now we know that this 13 goes right there, okay? All right, so perfect. So now we can list the sine of theta, okay? Then we can list the cosine of theta and all those, okay? So let's do the sine of theta. Well, look where theta is. Theta is right there, okay? So theta is right here. So remember, the sine of theta is the ratio of sides, the opposite side, opposite of that angle theta, okay, over the hypotenuse, okay? So if this is my angle right here, then the side opposite all the way across is way over here. It's at 12, okay? So that is going to be my opposite side. Over the hypotenuse, well, that was 13, remember? All right, so my hypotenuse was 13. So the sine of theta equals 12 over 13. All right. Let's do the cosine of theta. All right, the cosine of theta is the adjacent side over the hypotenuse, okay? So if here's my theta, the adjacent side is the one touching it or next to it, that's adjacent. So that's the 5 over the hypotenuse 13. So 5 over 13. Then the tangent of theta, well, it equals the sine over the cosine, or if you have a triangle to look at, it just equals the opposite over the adjacent. So if this is my angle, the opposite side is the 12, over the adjacent side is 5, so 12 over 5. All right. And then very quickly we can do the cosecant of theta. Okay, that's just the reciprocal of that, so it's 13 over 12. Then we can do the secant of theta. All right, that's the reciprocal of that, 13 over 5. And then the cotangent of theta, and that's going to be the reciprocal of that, so 5 over 12. Okay. You know what? That's so funny. I totally, jeez, man. Oh, no. I'm right. Hang on. I think I'm, am I just imagining things? 12 over 5. Okay, yeah, it's fine. For some reason I was looking at it cross-eyed. Okay, one thing that might help too, okay, is if you practice this. SOHCAHTOA, okay? SOHCAHTOA. It's a nice little, there's a story. If you want, look it up online, okay? I don't have the time to tell you right now, but SOHCAHTOA, she's some sort of like Native American princess or something. Anyway, whatever. Look it up. It's an interesting story. It's cute. But anyway, S stands for sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. TOA, tangent, opposite over adjacent. Okay? So it's all this stuff you have here, but in a nice, neat little package. SOHCAHTOA. Okay? All right, let's do another one. Let's try to find the 5 other trig functions, okay? So find the 5 other trig functions. All right, and if I give you something like this, the sine of theta is equal to 3/5. Okay, the sine of theta equals 3/5. All right, can you find the cosine of theta, the tangent of theta, the geez, I am having trouble here. The secant of theta is going to be, I'm sorry, anyway. I'm having a hard time, I'm distracted. The cosecant of theta, the cosecant of theta is going to be, we know that one already. And then the secant of theta, okay. All right, and then the cotangent of theta, okay. All right, so now we can do the cosecant of theta, that's just the reciprocal, right? So that's 5/3, okay? But for the rest of the guys, we need to figure it out, okay? So if you draw a triangle, okay, you can always draw a right triangle, all right? Put an angle right here, theta, okay? And if you know that the sine of theta is 3/5, remember this is opposite over hypotenuse, okay? Then if this is my angle, then the opposite side is 3, and the hypotenuse is always over here, so that's 5. And you can use the Pythagorean theorem, so 3 squared plus question mark squared equals 5 squared. And you'll end up getting that this side right here is 4. Okay, I'm not going to do the Pythagorean theorem for you. All right, so now we have that guy. Okay, so now just fill it out. Fill it out. Cosine of theta, right? Here, watch. I'll go so, toa, right? So now if I'm looking for the cosine of theta, I know it's going to be adjacent over hypotenuse. So adjacent over hypotenuse, 4/5, okay? All right. And the tangent of theta, well, tangent is opposite over adjacent. So here's my angle. So opposite 3 over adjacent 4, okay? So 3/4. And now just do the reciprocals of this guy right here. To get the secant, we have 5/4. And then this guy is just going to be 4/3. It's just the reciprocal, 4/3. Okay? All right, and it's really that easy. Okay? All right, cool. I might have to break this up into a second video, but let's see how long I can push it. Okay? Let's do part B. Part B, trig values. All right, for special angles. All right, might actually be able to make it, okay? And what we're gonna do is look at unit circle, okay? All right, so let me get my unit circle and I will show you exactly what to do. It's really nice when you have this. Hopefully you filled it all out, okay? Once you have all these coordinates filled out, the sine of a 30-degree angle is going to be 1/2. So put sine right there. The sine of 30 degrees is 1/2. The cosine of 30 degrees is going to be the x coordinate, which is radical 3/2. So we'll put cosine right there. Okay? All right, so you're just going to go around. The sine is the y coordinate for all these. The cosine is the x coordinate. And then the tangent is just the sine or the y coordinate divided by cosine, the x coordinate. Okay? All right, let's see what we get done in a minute and a half. This is going to cut it close. But yeah, let's see what we can do. All right, let's do an example here. All right, find the value of x. So here we go. Find the value of x. All right, so here's our example. It's going to be very rushed. All right, I have 30 degrees right here, okay, x and 8. All right, I think I will make another video anyway, just so we're not rushed. All right, I'm gonna cut it off right here and I'll start a new video. All right, see you guys in a second.